variable, right? So what we are going to see today is the artificial variables. Artificial variables. Right now, up till now, if you go back and see all the numericals, now we have dealt with only one type of inequality. So inequality that we have dealt with, I don't think you have paid attention in in the smallest in that particular smaller context. But if you if you see, and all the numericals that we have solved are of this particular type of inequality. So this is lesser than or equal to type inequality, right? And no, when we have considered this type of inequality in our constraints, we have used what? We have used slack variables, right? So we have used slack variables, right? S1, S2, S3, right? Now what will happen if the inequality is greater than or equal to type, or we have is equal to type of is equal to sign in your constraints. So at that particular at that particular time, the slack variables are not of any use, and at that particular time we are going to use the artificial variables. Now artificial variables are they don't have any physical meaning, right? So these variables are you can say that these are fictitious variables only, and they have no physical meaning, right? So they have just been used to to get the initial basic feasible solution, and when we get the initial basic simplex solution, we try to remove them from our solution. So that was the strategy. Even it was the same strategy that we have used in the slack variables. The same strategy we are also going to use for the artificial variable. So it is just used for framing out your initial simplex table, and after framing out of your initial simplex table, we are targeting, or we have developed a process in which these slack variables and artificial variables will now they will be moving out of from the final optimal solution, right? So they particularly are fictitious, and they have no physical meaning. They will be assuming the role of slack variables in the first iteration, and then they will be getting replaced at the later iterations. So they are merely a device to get the starting basic feasible solution, so that the simplex algorithm can be applied in the further iteration process. Now when we are going to see this, the artificial variables can be used in two techniques. So the techniques to use are two. The first one is the big M method. And this particular method was developed by A. Charnes, and we have two-phase method, right? So in both these methods, we are going to use this artificial variables, right? So this method was developed by Danzig, Orden, and Wolfe. And these are the names of the mathematicians who have developed these methods, right? So now what we are going to do is, now we are going to start with the big M method, and we are going to see how this is to be used. So before that, I am going to write some points related with the big M method, or the steps that we need to follow. And while understanding the steps, you will be getting to know how this is how this has a huge similarity with your simplex method, and how it is minutely getting differed than your initial simplex procedure what we have seen. So there is a lot of similarity in the process, but initial framing you will be having some what you can say some different process that we are going to follow. So the major portion will be finding it to be similar that of your simplex process only, but minor changes, and this particular method will be called as the big M method. So big M method. So M in this particular case is nothing but the penalty that we are going to consider, and this M has a very big value. It is near to the infinity, but not a infinity, right? So it is having a very huge value. So that means we are going to ascertain a very huge penalty at a particular place, so that that particular variable won't be appearing into your optimal solution. So for a particular variable, say specifically as we are going to see the artificial variables, so we are going to put a very huge penalty across a artificial variable so that this particular artificial variable do not come into picture while we get the optimal solution, right? So the first step that we are going to see is we are going to check whether the given LP problem is in the standard format, right? So express the given LP problem, that is linear programming problem, in standard format. So we already have seen in few lecture backs how is the standard format, right? So I won't be repeating here it again. So step 2 particularly, we have to add the slack. So even in this bigger method, we are going to consider both variables, slack variables as well as the as the artificial variables as well. So we have to add slack variables to the constraints that have this type of inequality, right? So less than or equal to, similar that we have seen in our few numericals earlier, inequality, right? So if there is a lesser than or equal to type of inequality, we are going to add the slack variables and subtract if the constraint has greater than, equal to, or equal to type of inequalities, right? So I'm hoping that no, you're getting it. So no, we'll have to add slack variables when where we have this less than or equal to type of inequality, and we have to subtract where we have this greater than or equal to type of inequality, right? So we have next step as step 3. Now for artificial variables, now what we are going to do, now that we have considered the slack variables, let's see what will happen if the for the artificial variables as well. So add artificial variable, we'll have to add artificial variables for constraints having greater than or equal to type size, right? So if a constraint has this type of inequality, that is greater than or equal to type of inequality, what we are going to do is we are going to add the artificial variables, right? So now this was regarding your constraints. What happens for the objective functions? So in objective function, what will happen? What will happen? Slack variables will have 0 as a coefficient. So irrespective of addition or subtraction in the constraint, slack variables will have 0 as a coefficient in the objective function. Now what will happen to the artificial variables? Artificial variables will also have the they will also have the coefficient. So what will be their coefficient? That depends upon the maximization and the minimization type of problem. So if maximization is there, so if maximization is there, we'll have to put if maximization problem is there, minus m penalty for artificial variables, right? And if there is a minimization problem, is there, what will happen? There will be plus m penalty for artificial variables, right? So plus m penalty for the artificial variables, right? So that we have to keep in mind. And already I have told you this m is it is very very high. It is near to infinity, but not infinity. And normally the m is greater than 0, right? So it is always m is greater than 0, and it has a very very big this thing, right? So let's begin with the numerical. There is one note that I will be sending you in the PDF copy as well. So So read out that that is related with what happens if we have the what happens if we have artificial variables in the optimal solution, or if we don't have artificial variables in the optimal solution. So what that particular indicate? Such type of note I have written, and that I will be sending it to you to the via the PDF copy on the note. So read out that, and you'll be understanding what they are trying to say. It is very simple. So now let's try and solve numerical with this particular regard, a very basic numerical, and let's see if no we can solve it. So there is a statement that has been given. So food X contains 6 units, 6 units of vitamin A per gram, and 7 units of vitamin B per gram, and costs 12 paise per gram. Food Y contains 8 units of vitamin A and 12 units of vitamin B per gram, and cost 20 paise per gram. The daily minimum requirement of vitamin A is 100 units, and vitamin B is 120 units. Find the minimum cost. Find the minimum cost of product mix by the simplex method. Right. So this is the theoretical statement that have been given to us, and with the help of this theoretical statement, what we are going to do next is we are going to frame out the objective functions and constraints first. We are going to check whether the objective function and the constraints are in the standard form. If so, we are going to move ahead, and we are going to consider the slack variables, artificial variables, and then we are going to try to solve this problem with the help of the simplex method. Right. So very firstly, now we have to decide the variables. So now what they are saying is that find the minimum cost of the product mix by the simplex method. So now the cost of the product mix is to be minimized, and the cost particularly will be what it will be particularly with related with the prices of the vitamin, and the prices will vary depending upon the units that we consume, right? So the units will be here what the units or the the grams of the foods of your X and Y will be the variables. Very simple to understand. So let X1 and X2 be the grams of food X and Y to be purchased, what we can say, right? To be purchased. So then what will be the problem? Then objective function will be what? So X, the cost of X is the cost of product food X is 12 paise, right? So 12 X1, and that of your food Y is 20 paise. So it is 20 X2. 12 X1 plus 20 X2 will be your objective function, and that what we have to do is we have to minimize it, right? we have to minimize this particular thing. And subject to, so what are the constraints? So constraints are related with the daily minimum requirement of vitamin E and vitamin B. So the daily minimum requirement of vitamin is 100 and the daily requirement of vitamin B is 120. So what we can write is here is that, so 6x1 plus, for B how many, no, it is for 6x1 plus 8x2. The minimum requirement is 100 units, so it should be greater than or equal to 100, right? So it is 6x1 plus 8x2. So what is 6? 6 is the units of vitamin A in food X. And what is 8 here? It is the unit of vitamin A in food Y. Similarly, for your vitamin B, we can write the constraint as 7x1 plus, here we have it as 12x2. Minimum requirement of vitamin B is 120, so it should be greater than or equal to 120. And mostly, very importantly, we have x1 comma x2 should be greater than or equal to 0, right? So this is how we have got this objective function and the constraints for the given theoretical statement. Now we have to check whether this is in the standard form. So particularly the most important thing that we have to check is if the RHS side in the constraint consists of the negative sign. So here it do not consist of the negative sign, and hence we can proceed further and we can formulate the simplex problem. So formulate simplex problem. So formulation of the simplex problem that we need to do. So the objective function time being can be written partially. So objective function is minimize z is equal to 12x1 plus 20x2, right? Now constraints, what we are going to write? Constraint, subject to, the first is 6x1 plus 8x2. Now what is this particularly? Now the inequality sign that we have here is what? It is greater than or equal to. And when there is greater than or equal to, we have to subtract the slack variable. So what we are going to write here is minus s1. Now as there is greater than or equal to sign, we have to particularly add the artificial variable. So here we are going to write it as plus a1. So we can remove this inequality sign and it will be equal to 100. Similarly, our second constraint is 7x1 plus 12x2, and again the inequality sign that we have here is greater than or equal to, right? So for the greater than or equal to sign, what we'll have to do, we have to subtract this slack variable, as this is not less than or equal to sign, right? So if it would have been less than or equal to sign, what would have been done? We would have added the slack variables, right? And now here this sign is again greater than or equal to, so another artificial variable needs to be added and it will be equal to 120. Now the number of variables that we have is x1 comma x2 comma s1 comma s2 comma a1 comma a2 should all be greater than or equal to 0. So this is how the simplex problem is being formulated, and now we can work upon this simplex problem in the in the next few steps, and we can achieve the optimal answer for this numerical. So now let's particularly I'll be writing this statement again on the next page, and so that we can frame out our initial simplex table in a proper format, right? So the simplex problem that we have now is objective function is minimize z is equal to 12x1. Sorry, we didn't complete our objective function, right? So it is 12x1 plus 20x2. So I'll be telling you that also in this page. Subject to 6x1 plus 8x2 minus s1 plus a1 is equal to 100, and we have 7x1 plus 12x2 minus s2 plus a2 is equal to 120, and we can write x1 comma x2 comma s1 comma s2 comma a1 comma a2 is greater than or equal to 0, right? So we didn't complete our objective function, right? So objective function, what we can write is that no, the irrespective of the slack variable having positive or negative sign, its no coefficient in the objective function will be 0 only. So 0 s1 plus 0 s2. Now problem it is? The minimization problem, right? So minimization problem is there because it is a minimization problem. The artificial variables will have a positive m in your in your objective function. So it will be plus ma1 plus ma2. I'm hoping that it no it is not visible. Okay, so I'll be writing it upward. So plus ma1 plus ma2, right? So your objective function is 12x1 plus 20x2 plus 0s1 plus 0s2 plus ma1 plus ma2. It would have been a maximization problem. Instead of writing ma1, we would have written minus ma1. Instead of writing ma2, we would have written minus ma2, right? So I think that you have got this framing of your simplex problem. So we can move ahead and we can frame initial simplex table, right? So framing of the initial simplex table again. Yes, CJ, and we have basic variables, right? So we have 6 number of basic variables now. 1, 2, 3, 4, 5, 6, space for solution, right? Solution, all right? So now it is CJ. Here what are the variables that we have? x1, x2, s1, s2, a1 and a2, right? Now the coefficients across coefficient in the objective function for all these variables are 12, 20, then we have 0, 0, m and m, right? So now by the time, I don't know if you have understood this or not, but your basic variables, the number of basic variables that you are going to take depends upon the number of constraints. So here how many constraints are there? Here we have 2 constraints. So how many basic variables we are going to consider? Firstly are the 2, right? Now very important thing that I'm going to tell you, if in the constraint you have both slack variable and artificial variable, so artificial variable is to be given priority for the basic variables. So if in our first constraint, if we see, there are slack variable, there is slack variable s1 and there is slack and there is artificial variable a1. So for the basic variable, when writing the basic variable in the initial simplex table for the first step, you are going to give priority for the artificial variable. So here what I have written here firstly is a1. Similarly, in second constraint, there are both slack and artificial variables. So hence the priority is to be given to your artificial variable only. And the variable that we have, artificial variable that we have is a2. What are the coefficients for this a1 and a2? It is m and it is m, right? So now let's fill up this table. So for considering our first constant, so it is 6x1, 8x2, right? Minus 1, right? Then it will be 0. A1 will have coefficient as, particularly A1 has a coefficient as 1 and A2 will have the coefficient as 0, and the answer here will be 100. Similarly, if we consider our second constant, here we have 7x1, 12x2 minus s2, right? And plus a2 is equal to 120. I'm hoping that you have understood how we have written the numbers in the initial simplex table. Now that we have written this, what we are going to do ahead is we are going to find out the values of zj, and then we are going to find out the values of cj minus zj. So here the values will be what? It will be for the first variable x1, it will be 6m plus 7m. 6 plus 7 is 13, right? So here we are going to write it as 13m, right? Nextly, 8m plus 12m will be equal to 20m, right? Nextly, minus m plus 0 will be equal to minus m. Here it will be 0, minus m will be equal to m, right? Here it will be, it will be m, and again here it will be m. Here similarly 100m plus 120m will be equal to 220m, right? So now Cj minus Zj, Cj minus Zj, right? So firstly it will be 12 minus 13m, so 12 minus 13m, so written to be written properly, it is 20 minus 20m, so 20 minus 20m that we have written. It is 0 minus minus m, that means it is m. It is 0 minus m, that means it is minus m. M minus m is 0. M minus m is 0. Now we have to see whether no, it is a minimization problem, and for the minimization problem, what is the constraint? What does the optimality check say? All Cj minus Zj values should be greater than or equal to 0, right? So it is for the minimization problem. So let's check whether all Cj minus Zj values are greater than or equal to 0 or not. Now firstly, no, we have 12 minus 13m and we have 20 minus 20m. So now here, no, we have to check whether which of this is having the higher side. Now we can now particularly assume the values of m here, right? So let's assume a very high value of m here. So let's assume that m value is 1000, right? So if we have 1000 value, so now it will the equation be, if the m is equal to 1000 here, so what will be the equation? What will be the answer? 12 minus 13, no, 12 minus 13,000, right? So 12 minus 13,000 will give you the value as minus 12 minus 12,988, right? And the other value is also now 20 minus 20m. So here also assuming m as 20, so 20 no minus 20,000. So what will be the value? It will be 19 minus 980. Among this, which is the highest value with the negative sign? This particularly will be the highest value with the negative sign, right? Or particularly you can check whether the criteria is fulfilled or not. Sorry. So for the criteria fulfillment, all Cj minus Zj values are greater than or equal to 0. But here 12 minus 13m is equal to minus 12,988, and your 20 minus 20m is equal to it is equal to 19,984, right? So here only we can say that all Cj minus Zj values are not greater than or equal to 0. Now we have to choose the entering variable and the leaving variable. So we have to identify the key column and the key row. So key column is to be identified as it is a minimization problem. So key column will be a maximum value with a negative sign. So maximum value with a negative sign comes for 20 minus 20m, and hence this particularly is decided as our entering variable, and this will be our key column, right? Similarly, we have to now identify the key row. For identification of the key row, we'll have to find out the ratio. So it will be 100 by 8, and here it will be 120 by 12. It is equal to 120 by 12 is equal to 10. So what is the value of 100 by 8? 100 by 8 is equal to 12.5. So amongst this, living variable is to be found out with a positive value having least positive value, right? So 10 is the least positive value because 100 by 8 is equal to 12.5. So this is your leaving variable, and this can be marked as your key row, right? So I think that you have understood this particular thing, and we can move ahead with the table formation, right? So now let's move ahead, hence iterate further. So we can go with the next iteration. So for the next iteration, what we have, there are 1, 2, 3, 4, 5 and 6, and this is our solution. So this is our CB, this is our CJ, this is our basic variables. Now solution. So x1, x2, s1, s2, a1. Now what? Now I've specifically written this particular column a2 as well, but there is no need of writing this a2, right? So I'll be telling you what I'm going to do here. So it is x2 and v. Oh sorry, this will be a1 only. A1, and instead of a2 we are going to write our x2, right? Sorry. So it is 12, 20, 0, 0, M and M here. So there is actually no need of writing this column. So now that I have written, I am going to cross it. And if you do not write this column, then also you are going to, no, it is okay. This is only for big M method, not to be generalized. This is only for big M method. So in big M method, the artificial variable, when it is leaving, you can cut down that artificial variable column, right? So I'm not, that particularly avoids the, calculation point. Now, a1 has a coefficient of m and x2 has a coefficient of 20. So this is going to be challenging, but let's move ahead. So now how to now consider the key row? The new values in the key rows will be what? It will be the old values divided by the key element. So your key element is 12, right? So the new values will be what? It will be 7 by 12 here. It is 12 divided by 12, it will be 1. 0 divided by 12 will be 0. Minus 1 divided by 12 will be minus 1 divided by 12. 0 divided by 12 will be equal to 0. And 120 divided by 12 is equal to 10. So this is how our first row, particularly will be fulfilled. Now in the next row, what we are going to do, we are going to find out the new values. I've already told you the formula, and that particular formula will have to be applied. So here the formula can be written as 6 minus 8 into 7 divided by 12, right? So 8 7s are 56, 56, 6 minus 56 by 12 will yield you, the value as minus, the value will be plus 4 by 3, right? Similarly, the next value here will be 12 minus 8 into 12 divided by, it will be, it will be 12, just a second. It will be 8 minus 12 into 8 divided by 12. So it will be 8 minus 8, and that will be equal to 0. Next value will be what? It will be minus 1 minus 0 into 8 divided by 12. As it is 0 that comes here, so it will be minus 1 only. The next value, the next value, बोलो. 6 and 7 चा कसं काय? 12 minus 13m. What is the value of 12 minus 13m? Considering m value as 1000. Just a second. Keep the call. I'll be explaining in the session. Okay. Okay. So now it is now. Yeah, there was some confusion. So let's check. What is the value of 12 minus 13m? So 12 minus 13m is equal to 13. We have considered the value as 1000, right? So let me do the calculation. 12 minus 13,000, right? 12 minus 13,000 comes out to be minus 12,988. And your 20 minus 20m, 20 minus 20m is equal to what? It is equal to 20 minus 20,000. It comes out to be minus 19,980. So what we have to select is the maximum value with a negative sign. So if I have to select the maximum value with a negative sign, which is the bigger value, it is 19,980. It is a minimization problem. So in maximization problem, we select a maximum positive value, and the minimization problem we select a maximum value with a negative sign. So that is the difference between your maximization and minimization problem. If there is any confusion, Swapnil, if you have, if your confusion is cleared, you can write it in the chat box, because we have followed the same procedure in our previous numericals also, right? So now this particular, what I'm telling this, you should write at, the top of the paper something, so that because of that there won't be any confusion, right? So write it on some important, you can make a different paper, different sheet, and on that what I'm telling, important that you can write. It is not only for Swapnil, right? But all for, for all others also, you make a habit so that the important points won't be getting mixed and it won't be creating a confusion, because what will happen is that you'll be remaining in the doubt, and the doubt won't be getting clear, right? So I think that you have understood this, right? For all the students, what I want to tell is that don't sit idly for listening the, listening my lecture. You should have your pen, no, you should solve with me these numericals, then only you'll be understanding. No, it is not a theoretical lecture like all others lecture. So try to get involved, and then only you'll be understanding. Otherwise, in examination it will be very very difficult. We already are into our fourth unit, right? So now for S2, right? So for S2, what we can write is, for S2 we can write 0 minus, 0 minus 1 into 8 divided by 12. So if you do the, if you do the calculation, it will be equal to 2 by 3, right? And lastly, for A1, it was 1 minus 0 into 8 divided by 12. So the answer will be 1 only. For the solution part, it will be 120 into 8 divided by 120 into 8 divided by 12, right? So actually it can be written as 100 minus 120 into 8 divided by 12, and the answer that will be coming out will be 15. So I'm hoping that it will be coming out to be 20, not 15. It will be coming out to be 20. Right. So as there is no space, I'll be writing it on another page. So what we have to do next is, we have to find out the Zj values, and then we'll have to go for Cj minus Zj values, right? So first Zj value can be written as what? M into 4 by 3 plus 20 into 7 by 12. So if you do the calculations properly, use your calculator, right? So calculator is a device that will be helping you to move fastly. Otherwise, you will be you will be finding yourself to just play with the numbers, and now no output will come. So calculators will be helping you in a very proper format. So here we can write it is 4m by 3 plus it will be 35 by 3. So this is the entire value that I'm writing because of no space here, right? Similarly, in your x2 column, I can write this particular thing as it is, it can be only 20 here, right? For S1, I will have to write it as minus m here. For S2, it will be 2m by 3. It will be minus 5 by 3. Just doing the calculations, you will be finding that this particularly comes. Or should I write it more properly? No, it is, I think that it is understandable. And here you will be getting it as m, right? Lastly, here it will be 20m plus 20 into 10 will be equal to 200. So 20m plus 200 will be here, right? So now what will have to do is, we have to find out Cj minus Zj. So Cj minus Zj will be what? 12 minus 4m by 3 minus 35 by 3, right? So it is 12 minus 4m by 3 plus 35 by 3. That particularly will be yielding you the value as 1 by 3 minus 4m by 3. It will be 1 minus 4m by 3, right? So now it is 20 minus 20, the value will be equal to 0, right? 0 minus minus m, the value will be equal to m, and lastly it is 0 minus 2m by 3 minus 5 by 3. So only the signs will change. It will be 5 by 3 minus 2m by 3. So this is how this particular will work, and m minus m will be equal to 0. Now we'll have to check if all these cj minus zj values, are equal to, are greater than or equal to 0 or not. So all cj minus zj values for the optimality should be greater than or equal to 0. So if you check this 1 by 3 minus 4m by 3, again you can consider the value of m as 1000, right? And again for the last thing also, it is 5 by 3 minus 2m by 3. So even this here also you can consider the value of this as the 1000, right? So can you tell me amongst these two, which is the value which will be the entering variable as of now? You can tell in the chat, tell me in the chat box whether it is no x1 or whether it is s2, depending upon the values, considering m value to be 1000. Can you tell me in the chat box? Simple calculation. Yeah, many of you are telling me that the value that is coming out to be as an entering variable is your x1, right? So it is right. X1 will be your entering variable here, and no, depending upon that, we'll have to find out our leaving variable. So this happens to be our key row, sorry, key column, and then we'll be finding out the key row. So here it will be a ratio that we are going to find out. So 20 divided by 4 by 3. So 20 into 3, 60. 60 divided by 4 comes out to be 15. And here it will be 10 into 7 by 12. So it will be coming out to be 120 by 7. So 120 by 7 and 15. Amongst this, 15 particularly is on the lower side. So this will act as a leaving variable, and this row will act as what? It will be acting as what? It will be acting as your leaving variable. So now that we have got this as the leaving variable, now we have to proceed further, and we have to think, which is, we have to think how the next iteration values will come. So right, so this is not hence iterate. So if we move ahead, let me construct the table again here. So it is CB, CJ, basic variables, right? So we have 1, 2, 3, 4, 5, 6, and again a solution, right? Right, so here we are going to write it as solution. We have x1, x2, s1, s2, a1, a2, right? Here it is m, right? Nextly we have 0, 0, and we have 12 and 20. Again, the entering variable was your x1 and leaving variable was your a1. That is to be remembered while writing the values of these particular thing. So here it will be Zj, it will be Cj minus Zj here, right? So instead of A1, I'm going to write X1. Here it is X2. So here it is 12. Here it is 20. We have to find out the new values in the key. So 4 by 3 is our key element. So 4 by 3 divided by 4 by 3 will come out to be 1. Here it will be 0. Here it will be minus 3 by 4, right? 1 minus 1 divided by 4 by 3 will be minus 3 by 4. Nextly we have 2 by 3 divided by 4 by 3. So 2 by 3 divided by 4 by 3 will be equal to 1 by 2. A1 and A2 we have particularly have displaced. There is no need of finding out these two values. Solution here will be same. So it is 20 into 3 divided by 4. It will be equal to 15. So the new values again you can find out. You can try it out. I will be just reciting them. So no, the first value will be 7 by 12 minus 7 by 12 into 4 by 3 divided by 4 by 3. So it will be 7 by 12 minus 7 by 12. It will be equal to 0. Next will be 1 minus 0 into 7 by 12 divided by 4 by 3. So it will be 1 only. Nextly we have value as 0 minus 1 into 7 by 12 divided by 4 by 3. So if you do the calculation, the value will be coming out to be 7 by 16. Nextly we have the value as minus 1 by 12 into 2 by 3 minus 1 by 12 minus 2 by 3 into 7 by 12 divided by 4 by 3, and the value will be coming out to be minus 3 by 8. Lastly we have the value as 20 into 7 by 20 minus 10 minus 20 into 7 by 12 divided by 4 by 3, and the answer that you will be getting is 5 by 4, right? So we can find out what is the value of Zj. So here it will be 12, here it will be 20. For S1 and S2 it will be minus 1 by 4, and here it will be minus 3 by 2, right? So moving ahead, now we have to find out Cj minus Zj. So 12 minus 12 is 0, 20 minus 20 is 0, 0 minus 1 by 4 is 1 by 4, and here it is 0 minus 3 by 2 will be 3 by 2, right? Similarly 12 into 15 plus 20 into 5 by 4 will be giving you the value as 205. So here what we can say is that all Cj minus Zj values. So let me move to the next page. So all Cj minus Zj values, if you see, are greater than or equal to 0. Hence your optimal solution is reached. Hence the optimal solution is reached. Now you can find out the values of x1, x2, and we can find out the value of, was it a minimization problem? Yeah, it was a minimization problem. So Z minimum. So you get the value of x1 as 15, x2 as 5 by 4, and Z minimum as 2 by 5, which finishes your answer.